Hello and welcome to another episode from Spiral Physics Education. So I'm going to be looking at one of the core practicals, and this is to do with electrical circuits. So there's a few different practicals to do with this. So the first one is that you need to be able to set up a series and a parallel circuit, and you need to be able to calculate the resistance of a series and parallel circuit. And you also then need to be able to do the IV characteristics of a resistor and a filament lamp, which was covered in episode 7F, the IV characteristics. So we're going to revisit it here a little bit. So before you get going, make sure that you're very, very comfortable with how current behaves in series and parallel circuits. Same thing with potential difference or voltage. And please make sure that you know Ohm's law very confidently before progressing, and if you're not sure about any of those, do check out some of the other videos on the channel to help you get up to speed. So the first thing is that you will be given two resistors. I'm going to call them R1 and R2, and you're going to be doing a few different things with those two resistors. But the first thing is that you need to know what their resistance is. So you will get resistor R1 and place it in this circuit with a power supply, an ammeter and a voltmeter. The ammeter is measuring the current, the voltmeter is measuring the potential difference. And with that circuit then, you would then, with those measurements, use Ohm's law to calculate the resistance of R1. And then you would take the resistor R1 out of that circuit, replace it with resistor R2, and then repeat it. And that way you could use Ohm's law then to calculate an accurate value of R1 and R2 before moving on to the next part of the experiment. In the next part of the experiment, you have to make a series circuit with your resistors R1 and R2. Now remember, you've done some measurements with R1 and R2, so you can actually calculate their individual values. But in this circuit, we're trying to measure the combined resistance of them in this combination, in this series combination. So what we need to be able to do is record the potential difference using the voltmeter and the current using the ammeter. And then we use Ohm's law, and we still use R is V over I. But remember that that provides the total resistance of the circuit. Third circuit will then be a parallel circuit with R1 and R2, and you repeat the process again. So once you've done that, you've got the potential difference from the voltmeter, and you've got the current from the ammeter, and you use Ohm's law, and you record the current and potential difference and calculate the resistance using Ohm's law. But remember, this will give you the combined resistance of those two resistors in this combination. So to help you out a little bit, so we've got some made up data from the experiment that you've just done, let's say. We've got all the potential differences and all the currents, and what we might get asked to do is to calculate the resistance for each of the circuits. And we just use Ohm's law to do that. And you notice that the first two, R1 and R2, have got identical potential differences and current values. So that means that they are identical resistors for R1 and R2. And calculating it for R1 and R2 in series, we get 40. So if we look at that a little bit carefully, when you place R1 and R2 in series to get 40 from two 20 ohm resistors, that's the sum of the individual resistors. So when in series, it looks like the total resistance would be the sum of the individual resistors. So let's have a look at the result that we get in parallel is 10. So 10 is half of 20. It looks like by adding two resistors R1 and R2 in parallel, we've actually halved the resistance. So to summarize that, when you place R1 and R2 in series, the resistance is doubled. So two 20 ohm resistors in series, the resistance is 40 ohms. However, two 20 ohm resistors in parallel, the combined resistance is only 10 ohms. So the resistance decreases. So the next part of it is to look at the IV characteristics of a resistor. So here's the equipment, and to go through it, they've got a power supply at the top, probably a few cells or one of the variable power supplies. We've got an ammeter to measure the current, the voltmeter to measure the potential difference, and the variable resistor. And also the device being investigated with this occasion, it's going to be the resistor. So you need to state, if you're ever writing a question about this or answering a question about this, is that you need to state that the ammeter is used to measure the current and that potential difference is measured by using the voltmeter. And we need to come up with a range of different potential differences and currents by varying the variable resistor value across its whole range to try and get as many bits of data as possible. Now you could do this practical. Rather than having a power supply and a variable resistor, you could instead have a variable power supply, but that is a completely different circuit symbol. So if you wanted to do it that way, make sure you know what the circuit symbol is for a variable power supply. So once you've done that, then we need to plot a graph of current against potential difference, and the reason for that is that current is going to be your dependent variable, and potential difference is your independent. That means that in that experiment we were changing the potential difference, and the current changed as a result of that, or the current depended on the potential difference. And the result of that is that we get a straight line, and that means that current is directly proportional to potential difference, and that means that we've got a straight line that passes through the origin, and that proves that that device obeys Ohm's law. And we could calculate the resistance by taking a value of PD and a value of the current, and using R is V over I to calculate the resistance from that graph. Okay, so the next one is the IV characteristics of a filament lamp. So we used a very similar circuit, taking out the resistor, replaced it with a filament lamp, and this time, because the filament lamp's usually going to be 12 volts, we need a 12 volt power supply. But we've still got a variable resistor, an ammeter, and a voltmeter. So if you're ever writing about these things, set up the circuit, and you're going to set up the variable resistor so that it's at its lowest setting. And what we're going to do then is record the current, and using the ammeter and the potential difference, using a voltmeter, always state those things. And we're going to vary the position of the variable resistor across its whole range, recording a whole range of values of current and potential difference. And when we do record a whole range of values for something, that means we can plot a graph, and the graph will look like this. It will be a curve, and we're going to plot current against potential difference. And we can say, when we're looking at it, that straightforward, as potential difference increases, so does current. That's a basic statement about the shape. However, we need to come up with a much more detailed description of it, and we can say something on the lines of as current increases, there's current and there's PD. As potential difference increases, current increases, but by smaller amounts. Or we could start off by saying that the increase in current decreases at higher PDs. So it's important to try and explain that the gradient is decreasing, and that's a way of doing it. So another point to say is that the gradient is decreasing, and because we remember that the gradient is linked to resistance, when the gradient decreases, the resistance is increasing. But we need to know why, and that's because at higher potential differences in currents, the lamp is hotter, there's more energy going to it, so it gets hotter, and that this causes the positive ions in the lamp's wire to vibrate more, which causes more resistance to the flow of charge. So that explains why it curves the way it does, because the resistance is increasing. So with these practical questions, then we get some questions that go on the lines of how would you investigate. So think about this: how would you investigate the IV characteristics of a resistor? And the key thing is that you need to mention equipment or draw a diagram of the equipment. You need to do some measurements, possibly some calculations. You might need to mention the range or consider the range. For instance, if you were heating up water, you can make ice at 0 degrees Celsius, and you could boil the water up to 100 degrees Celsius. So there's a very clear range of values there that you can comment on. Always good to comment on reliability, how you're going to make it more reliable. If appropriate, what type of graph you're going to plot. And when you're looking at the graph, what you're going to look at or for or from the graph, it's going to tell you something, or what shape it's going to be. And also, if there are any particular improvements, they might get asked specifically about how can you improve this experiment, or what restrictions are there to getting accurate results from it. And they might also ask you about safety. So we've got lots of different things that we can comment on there during our investigation. And just removing all of the words, when I gave this to one of my year 10 students a few years ago, they came up with a little saying to help you remember the order of this. And obviously they came up with something that reflected how they thought about themselves. So experiments must contain really, really good looking, intelligent students. But what they actually found difficult was, once they remembered that sentence, then they found it difficult to remember that experiments meant equipment, must referred to measurements, and contain then actually meant calculations. So although it's a good idea to do this, make sure you understand what the EMCRRGLS is actually trying to help you remember. Okay, so let's say in an exam that you had the question, how would you investigate the resistance of a filament lamp? So we're going to use that approach to try and answer this question. So the first thing was experiments must contain really, really good looking, intelligent students. So experiments, equipment. So the first thing I do, I would set up that equipment. Measurements, well, I would then vary the variable resistor and record the current using the ammeter and the voltmeter to measure the potential difference. And that means I would make sure that I was going to measure the potential difference in currents for a whole range of different resistances of the variable resistor. I can't comment on that range because I'm not sure what it would be. It depends on the type of variable resistor that you've got. There's not much else I can say about that. So graph, let's go to the graph. Plots a graph of current against potential difference, and I think it will be a curve that will start from the origin, and as the curve goes, as the current and potential difference increases, I think that it's the gradient of the graph is going to decrease. And then at some point I could calculate the resistance using Ohm's law, which is R is V over I in this form. So let's have a look at it. So I've got my variable resistor and ammeter and voltmeter in there, but the ammeter and this will give me these two positions here. If an examiner looks at that, those are definitely points that get you marks in an exam. So showing that you can have an ammeter to measure current, you've got the potential, you've got the voltmeter across the filament lamp to measure the potential difference, and also you've got something in there to vary the potential difference and current in there. So those things there will get you marks for E equipment. Saying that you're going to measure the current is a measurement score, that will get you a mark. Saying that you're going to use an ammeter to do that is going to get you a mark. or potentially get you a mark. And then doing the same with the voltmeter and potential difference are also M marks. So remember, M meaning measurements. So considering a range, well, I can't put any values on it, but that's a comment on the range. At least I considered it. And then looking at the graph, I've mentioned I'm going to put current on the y-axis. I'm going to put potential difference on the x-axis. Those are my graph points. And then I think it's going to be a curve, which is what it will look like. And also I mentioned an advanced statement saying that I think the gradient is going to get smaller as I increase the potential difference. And that's also a point at looking at the graph. And then I've stated an equation there, which is a reference to the calculations. So that will get you a decent number of marks, if not all of full marks, on answering an investigation question in an exam using the experiments must contain really, really good looking intelligent students. I haven't done any safety on there because it's usually quite safe, and we haven't got any improvements on there because this one, well, there's not really any point to improvements. And we could have actually done some reliability by repeating if that had come up in the question. So that's the sort of thing that you could use when you've been asked to investigate or write up an investigation. So I hope you found that useful. Don't forget to subscribe to the channel and check out some other videos on spiral physics education, and see you next time. And hopefully that's helped you learn a little bit more about the core practicals that you're expected to do, and hopefully that will get your grades boosted as well. And see you next time on Spiral Physics Education. Goodbye.